Okay, in this video, we're going to be making the rotor for the brakes right here. We'll be making the bearing and also the C-ring as well. And we might have a fourth bonus item, so stay tuned for that to see if that is a required part. So as usual, we don't have specifications about these as far as drawings made by Polaris. All we can really do is just get a picture of these from the internet and do our best to reverse engineer them. And because we're trying to use these for our own purposes and we're not trying to manufacture these, then this is a valid way of doing reverse engineering. I use paint.net a lot of the times for cropping images. So I'm going to pull that up, see if it'll pull up here. And you can just use Google, I'm sorry, you can probably just use Microsoft Paint if you want to. But you know what? I think we talked about this in the last video. Okay, I'm not seeing anything getting pasted here. So we talked about this in the last video as well, that you could use the snipping tool, SNIP, this. So if you don't have paint.net or Photoshop loaded up, you can probably just position right there. It's kind of tricky because you have to train your mouse to do the right thing. You can say new. Ah, gosh, so close, right? It wants to adjust by itself. So we'll just leave it like this right here, new, and that just means we'll have a lower resolution, excuse me, a lower resolution of the image. Once this comes up, you can right click on it and say save as. Let's put this on our desktop called Rotor. I believe that's what the official name of that is. And while we are here, we should probably go look to see if there's a picture of the other two things, at least some kind of profile. This is not exactly what we're looking for, but this is a top view, so that will probably work. So going over here to the snipping tool again, just say new, and we'll get this right here. We're going to call this a snap. C-ring, I believe, not a snap ring. I don't think this is called a snap ring. Save as, and we'll call it a C-ring. There's a special tool that you put in those two holes and allows you to squeeze it to make it a smaller diameter so that you can fit it in and then hold this bearing into the knuckle or hub. So that's what holds the bearing into the rest of the wheel well. It's hard to say. Wheel weld. Okay, basically the cavity inside of the wheel. Next week we'll be working on this one, and I'm going to challenge you guys to make this knurling pattern and also the threads, kind of a review of some thread techniques, but that'll be next week. So let's get into these three parts. One of the things we remember from last week is that there's these standardized um, distances between these holes. So that's kind of a good place to start. And so we know that the separation between those, let's see, is it given here? A lot of times they don't share that information with you. So they just tell you what it's compatible with. Unfortunately, we can go back to our D2L assignment and we can go down to the assignment on the wheels and tires, or was it the hubs? You know what? I think it was a little bit of both, right? So if we look at the hubs, for example, that was last week. The separation between the bolts was given, I believe, in the description right here. So that's kind of the standard thing you would find in a part description for a wheel or a hub like this, or in our case, it would be the rotor. All right, so let's start off with this. There's a wheel right there from last time. Let's go ahead and, you know what? I think we should probably start with metric. We can always change later once we get the part started. Reason why we want to start as metric is, start with metric rather, is because that's the separation we have for the holes that keep the wheel on. All right, so this is a point where we go up here and we say insert, see where the insert is. Right there, insert image. We go over here to the desktop, hopefully, and we find our rotor. We will start with that one, place it here, and then do our standard thing that we've done before, and that is to try to place a point on the image there, and there. And then realizing that the separation distance between the two is going to be 156 millimeters. That's the diameter of the circle on which these reside. So the diameter of this large circle is, okay, we have to go right here in the middle, off to the side, 156. That's going to rescale everything, which makes it look good, like this. And then we need to maybe find the center of that. Let's see how we might be able to do that. How about connecting those 2 points that are kind of hidden there? And then you can see that you can't really find that part until you hover over it. I think we talked about like going around and looking at the other side, but that didn't really help any. So I think the only thing we can really do is maybe just put the size of this hole here. So try to get that right about there. And we can see where it says 14 millimeters. I forget from the video that we talked about last time what the diameter needed to be a through hole through which these bolts can pass. Let's hope that it's actually 14 or 15. I'm having a hard time remembering. Should we go for 15 just in case? Why not? All right, so at this point, we can right click on this piece right here, hide it so we can work on the rest. And that means drawing the circle that starts from the midpoint right along here somewhere. So let's see if we can find the midpoint right there at the green dot. Come out here all the way to that spot and then realize that this is not really a hole, but actually I guess, the center point. I don't know if it's going to let us use that though. Okay, let's just make it a construction line for a moment until we get everything else in place. Now, we know that these two have to be separated by that same amount, so that works. We said 15 millimeters for that one. We could use the circular or rectangular pattern to find it, but why don't we use our midpoint? And so we'll start here, and we'll go out in this direction, like that. Okay, and I guess we could lock it into that position. That would be a good thing. You can see that I purposely did not make it perpendicular so that I could force it to be perpendicular. And if we measure the distance of this right here, it better be, yeah, and it's also constrained already. Okay, good, 156. And so since it's only 4 holes, we will just manually do these other ones. In a moment, we're going to have a lot more holes in there, and we'll have to work through that. All right, let's look and see what the rest of this part looks like. If we take the image and say, look at the visibility, we can see that we only have a few of the things done. And so let's make a couple of other circles that will help us out. So the first one, we're going to start here and be concentric with that one and go all the way out to there. And we look at the numbers and you can see that the part was probably at a slight incline when they took the picture of this, because you can see it goes up high down there at the right-hand side, up the top. So we're just going to have to assume that we get something close. Now, right there it says 200, and let's just make it a 250, just assuming that that is the actual value. Okay, that might be okay. And then what we need to do is mark this area right here. So let's find something that is close to that one. Oh yeah, 250. And then go here and out to right there. I think we really need to focus on going out to this point though, because of the perspective of the things. So let's always go to the left, I suppose. And then we want to do maybe one more, and that is going up to this point right here. And it's not really consistent, is it, as we go around each one of these? Okay, but fortunately, we just need to get close enough so that when we model these parts and do an assembly, that they will actually fit together and you have no intersections. Now, what you're seeing up here as far as the pattern is concerned, I'm seeing 3 dots and then 2 dots. 3 dots and 2 dots. Um, that might be the way to do that, I guess. So let's just kind of take that approach and say there's one right here. And I'm thinking 10 might be good. And then we do another one right here. That one looks a little bit high, so I think it tried to force it to be at a certain level. Zooming in is probably going to be a good idea on this one. Let's always type in 10 each time. It's just slightly too big, probably. But that's okay for our brake rotors. All right, this one seems like it wants to line up with this one. I think we might have to let it. And then we got one more. I didn't do a good job on getting that centered. And I want y'all to be as careful as you can in reverse engineering these parts. Okay, and let's see if we got enough to work with. So let's right click on the image and turn off the visibility and see if we have enough here to work on. Now, what we might also do is to remember what we're trying to target here. We might pull up that part image just so we can see it, and that is the so-called rotor. And we'll pull it over here to the right-hand side and then squeeze this in using our Windows features. That way we don't forget about the shape. I'm thinking that all of these, through a control shift operation, need to be a construction line, at least for now. Okay, that would be good. Let's see. Anything else that needs to be a construction? You know what? Actually, this outer one does not need to be a construction line, so we'll change that one back. And then it's about getting the rest of this shape in here. Okay, so how should we go about doing that? Hmm. I'm wondering why this one is so close to that circle right there. It's probably because of that perspective thing. I probably got it a little too close, and I used this one in the wrong area. You can see that these are not really close to the outside. So that's okay. I'm just going to shift them up because I need to make sure this one does not cut into the metal because it clearly doesn't do it there. So this is one of the problems of reverse engineering and getting these low resolution images from the internet. The best we can do is really just approximate things. That's good enough for what our team is doing because we're trying to make a model to simulate the motion, not so much send these parts off to a machinist and have them make it. Okay, so what else could we do here? It looks like this is essentially going to be a fillet here and a fillet there. Maybe, or maybe a circle there. Wonder if we could use that to our advantage. So let's right click on the image again and say, make that visible. Let's try to put a circle right in here, and then we'll blend that circle into the other circle. So doing one right here out to that spot might be good. Okay. And then we might just draw a line just to guide us that there's some kind of line going from maybe right about here to right about there. Some artistry involved in this, right? Now we could make this one visible just for a moment, not a construction line, because we know this needs to blend into that one right there. In fact, let's just use that as our, yeah, like a tangent or something like that, right? Let's see if that will work. So first of all, what we're going to do is we're going to make this, line up and hit that. And I kind of moved off to the left. I didn't really want that to happen. So what I'm going to do instead is pull it in until it touches it. You can always go back here and say image and say visibility. Oh no, but you can't see the line anymore. Oh yeah, I guess you can kind of see it. Um, yeah, maybe if I hover over it like that and see how that line actually, that curve goes too far now. Okay, is that maybe something I need to change? Let's see. Oh, it looks like I aligned it with the bottom instead. Okay. The left-hand side is actually better. Okay, so it looks like my alignment was actually better down here. So I'm gonna try that one instead. You can continue doing what you're doing if you want to, but I'm just gonna say, what if I have a circle? Where's it at? Oh, did it put it here? Oh yeah. All right, never mind. Let's just stick with what we have up here. So we have this line here going in that way. All right, looks like we have to do a little bit of freehand, but we can do that. Let's make a line like that one, and it intersects at that point. Let's also make it intersect the circle as well. And in particular, let's make it go as a tangent. So right here and right there, that needs to be a tangent. Now right here, we need to have a blend. So that's going to be a bend, or in our case, we're going to call it a fillet. Let's just see if the default of 2 millimeters makes sense between those two surfaces. Well, it doesn't look like it's going to let us do that because we need to really cut off the part that we don't need. So let's do the other side of this. So going from somewhere along here to somewhere there. And in order to make them symmetric, I'm going to do a couple of things here. Maybe just one thing, just make them equal. So this one needs to be equal to that one. Oh, that's not good. Did I say parallel or something? That's what I did. All right, so we need to say equals, which is the horizontal one like that. All right, that does not look equal, but we're going to have to take its word on that. We could probably verify that these are okay, well, that it wasn't really that way already. Okay, not too bad. Now this little area right here is what we want to get rid of, and then we'll do our bend right there. Oops. Control Z if you accidentally shift the whole part over. At some point, you might just go ahead and go to the middle like this and say anchor that piece so that way we don't move the whole part around. Okay, what else we need to do here? Well, let's do some trimming. So we can split off this distance right here. So that's a part of its own. And then let's see if it'll let me turn that into a line like that. And then we go back and do the fillet here and here. And that's such a small fillet, I don't even think it noticed anything. So I'm gonna hit Control Z. I don't even think it did anything noticeable. So let's say fillet, and I'm gonna say 20 instead of 10, 2. And you can see that I got a little bit closer to that. It might be closer to 10. So we can just play around with that. 15, get it looking good. Maybe 10. Looks pretty good. Do the same thing over here. We really want to take advantage of rot our rotating pattern. So we don't want to do this 4 times. We want to do this feature one time and then be done and just rotate that pattern around. Let's split the rest of this off here, but it really needs to be split like all the way around. Let's see, I want to split it right there. All right, let's see if it'll let us turn the part that's not going to be part of the part, so to speak, um, into a hidden line. And look at that. That looks pretty good. Maybe a little too, I don't know, not enough round there, but we are going to go with it anyway. All right. So how should we start rotating this pattern around? Um, let's just see what would happen if we extruded at this point. And we'll take these points right here and make those construction lines, or those lines rather. And let's just see what happens when we extrude it. Now I can imagine it's only going to be about 1/8 of an inch thick, would be my guess on this. 10 millimeter is really not the size of this. Let's go down to 4, and that looks about right. If you hit OK, and then kind of take a look at it, its front face, you can see that we're kind of on our way here. I don't know how to make that any smoother. Something just does not look right there. I challenge you to make yours better than mine. I think it's because I made this circle right here concentric with that one. When really you can see this circle is actually probably concentric with that one back there. So I challenge you to make yours look a little bit better than mine as far as the curvature right here. And that's just a matter of pulling the circle back over to this point that defines that shape. If I wanted to go back and try to do it, I don't know that I really could. Let's go back over here, edit the sketch, and yeah, so here is this circle right here that I'm talking about. But you see, I've already butchered it all into different pieces and things like that. And so trying to move it center back here would be a bit challenging. Okay, I'm gonna let you decide whether you want to go back and do that or not. Um, we will just move forward like this and then start making some patterns. Okay, so will this be enough to at least give us the pattern on the inside? Let's try that first of all. So what we're going to do is say, just let's take this whole part. I don't know if this is really going to work though. Maybe we just need to take that part of it. I don't think this is going to work if we just take this whole thing and say, I want to make a circular pattern. Let's see if I'm right on that. I think it's just because these are going to be filled in by the rotation. But let's find out. Do a rotating pattern when you're in the 3D model. We want this to be repeated 4 times. And the direction that we want to go is around this direction here. What features do we want to select? I thought it already selected the whole thing. Let me select a feature. It's not seeming like it's happening. Let's go to this extrusion here and say we want to repeat this pattern. Okay, now it's got it selected. The direction we want to go is along the blue axis. No, never mind. Since our sensor is up there, not going to work. So we need to clear that out and say, I want this circle on the outside to define my axis. And I only want 4 of those. So did we get what we wanted? Kind of, right? I mean, that looks really good, actually. But what we need to do is go back, if we're going to be okay with this, we need to go back and drill those holes and treat them as a separate object. And you'll probably know how to do that. Just going back up here to the image and saying, make that visible, right? And I don't know if that's going to work or not. Let's flip around to the other side and say, can we use these circles to do a cut? So we're going to say extrude. We're going to say cut. It's going to say select the profiles. We're going to say we want this one, that one. Carefully selecting these. All right. And then we're going to go through the whole thing. And we're going to see if we did everything right. Looks great. That means we could take this extrusion and also apply a circular pattern because now we're cutting in a circular pattern. We've selected our features, which is those 5 circles. The direction is not around the origin, which is up there, but the center of this one. So select that. And you can see the pattern is along here, but it looks like it needs to be lined up a little bit better. So should we multiply it by 8? Is that closer? I think it is. So if we hit OK, do we get what we're looking for? Sure enough, and look at us. We go back up here to the sketch, hide the sketch, and we have made, folks, we have made a good looking disc rotor. Okay, so at the beginning, it kind of looked like it's going to take us a very long time, but using these rotating patterns is really going to help us out. This is one part by itself, so we can save it in the Baja folder. I think I probably need to change the folder a little bit. So I don't want it in the roll cage folder. I have a folder on my drive here called just Baja. So see if we can find something like that, and we will call that the brake rotor. And we have one part down. And it says, are you sure this is outside the project boundary? And that's because we're still in the project called um, roll cage, because I didn't change that at the very beginning. Now, let's see, what else do we have? We have to make a C-ring as well. So do we have a face-on view of the C-ring? C-ring, rather. Lots of tires here. File new. And It's a good, you know what? I don't really know what the size of that C-ring is. We saw it over here. We took a picture of it as well. Let's see where the image is at here. But it's also the diameter of this one right here. So it's pretty close to this diameter. This one's going to be easy to make once we get there. Hmm. You know what? I'm going to take a little snipping tool and I'm going to snip this one because I can get the diameter from this. Even though I can't draw on top of it, I can still get the diameter. Oh, no, I can't because I don't know the reference here. Okay, I guess we'll just have to say, do a search here based on these part numbers to figure out what the actual diameter is, and I'll do that. That's part of research, right? Engineering research is to figure out the size of these. Now, what I did was I ordered them so I could just go over there, but I'd have to take apart the vehicle in order to measure those things. So let's just focus on the C-ring first of all and get the shape. We'll go for metric first. We can always change that later. And let's just go ahead and do our save as while we're here. We don't want it in the roll cage folder. We want it to be back in this folder. And we're going to call this one right here C-ring. It's basically just a clip, as I said a little while ago, where um it's springy. It has a little bit of springiness to it. Going over here to our sketch, so that it can clip into a groove. And I'm not even sure if we put the groove. Oh yeah, the groove will be in the knuckle, so we'll have to get to that part a little bit later. These typically are setting up on a vertical. So we will go insert right here, image, grab that shape right here. It's a lot smaller than the rotor is. I want to say that it's like a couple of inches. So let me pause the video and show you how you would research this to figure out what the size is. Okay, so I think maybe the best place to start is our bill of materials. This is something that an engineer like yourself would want to know how to make, and that's basically give us a part a description, quantity, price, and cost. Those are the main parts of a BOM, a bill of materials. And so from that bill of materials, we can go and find that part, or you can go to because I think I have those all grouped together. You can go to a site of OEM parts like we did before. And this Rocky Mountain ATV has been a good resource for us as far as finding parts that fit together. That was really a big problem in our previous version of the Baja is getting parts that fit together. But we selected a 2021 RZR RS1 model right there. And now I need to go down here and find the OEM number. Let's see, that stands for original uh, manufacturer. What does that stand for? Origin equipment manufacturer. I think I have to look this up every week. Original equipment manufacturer. So what did Polaris call it when they made it? And is there some kind of aftermarket person or company that says I can make these so that they're the same size and fit as these that were made by Polaris. So if you try to buy these original ones that have the number 10 down here, here's the OEM part number. It would have cost me $12 just to get the C-ring. Um, if I bought it from Polaris. Now, if I go over here and just put in that number, sometimes it'll get it right. Yeah, I knew exactly what I was talking about. Um, but then sometimes you click on these things here and it doesn't really tell you what size it is. Because again, Polaris made this, so they may not even want to share the size of these things. We just got more pictures of it, more of the same. So then what you can do is, ask Google and then ask AI. So you can say, what is the diameter of C-ring? And so this can do like a deep search into the internet and find it. And we will also, yeah, you know what? That makes sense. It's about 3 inches if I remember right. So we will go with the 80.7 millimeters. It also talks about this here. We can verify it by it through other means, maybe even on that site right there. But we are going to move forward, assuming that that is correct. So starting with this, we can say that if you take a line and you go perfectly horizontal like that to its maximum position, that the size of that right there should be this. And it fortunately rescaled the part, which is good. Then you hope that um, that this is somewhat taken above the part, this picture, that is. Okay, it doesn't look like I hit the mark exactly. Should be green. So we'll go for that one and see if I hit the mark. Okay, so my question to you is, why was it a little bit high up here? It was dead on here. Why is it high down here? And that's because the picture was taken at a slight angle. So it's got some squashing in the vertical direction. That's called foreshortening when you do that in a photograph. So by taking the horizontal, that's probably the best thing that we could do for this one. The rest of it is going to have to be kind of an approximation. We have some thicker area up here and thinner right here. How in the world did they pull that off? So we can just, I guess, kind of guess about that part of it. We know we have some circles down here. So let's put these in place. A circle right there. Looks like it's going to be 3 millimeters. And then a circle over here, 3 millimeters. That. Uh, and then it looks like we have a curvature right there that we can deal with. So out to this point, right there, out to this point right here. And let's just use a couple of markers around all of this. So maybe get an oval that would fit, right? Or can we use this tool here? So maybe we'll use a 3-point approach. And that would be go along this horizontal until you're right here, go along this horizontal until you're here, and then just stretch up until you're short of really where you think it should be, if that makes sense to you. Now, we should also kind of stop for a moment and make sure that all of this is realistic. Because of the foreshortening, it can be kind of confusing. So right click on the image and hide it. Is it looking okay? Yeah, not too bad. Let's bring it back into view so we can finish up the bottom arc. So visibility, and I'm just using all of these reverse engineering approaches. I'm wondering why those two dots are separated. Oh, did I make a mistake here? Okay, maybe. Oh, it's actually saying the center of this one is a little bit down. And I'm okay with that. That's actually makes sense. It should be more vertical though. So I think I will say that we need to make these vertical, and it just adjusted it slightly. So I'm going to be okay with that. Now, the next thing I'm going to do is grab this and guess about how far it comes down. And then I'm going to pull the image up and then make sure that it's, okay, I think it's pretty thin right here, if I remember right. Okay, and we're going to pull that image up and then hover over it to see if I got close. We can probably then grab onto this and move it around. Let's hope so anyway. Reverse engineering, right? Look at that. Okay, I got pretty close. I might even be happy with that. I'm gonna try to get down here to the bottom of it and see if I can grab it and pull it in a little bit. Not gonna let me do that though. So we'd really have to fix those two endpoints, which we can try. You can just say, lock that in right there, lock that in right there, and can you just resize this a little bit? And maybe. Okay. So then hide. that. Do we have everything we need? Almost. We can take this, turn it into a construction line. Then we got to deal with this little piece right in here. So how do we want to approach this? In our image that we might pull up like this, file open, C-ring, you can see that it pretty much gets cut off right there at the circle. So we can just say, how about a line going from here all the way out to there, and then make it tangent to this. I'm afraid it's going to move that circle though. Okay, it did. All right, so what we want to do with that instead is we want to lock all this stuff down. So in order to do that, let's put a little lock here and a lock there. And then we also want to lock down the sizes, which means I better give these a size. And it looks like it's around 8 millimeters. And then we'll make this one equal to this one. So that way, we hope that when you're making these tangents, that it moves the right thing. So I think we did good on that. Let's see what else we can do. Did we meet up right there? Looks like we kind of did. I hope that meets up there. A little bit discontinuity, but we will not focus too much on that. All right, getting back to our cut, we're also going to do the same thing over here. Put it arbitrarily along this line, then zoom in. Like that. Now, how about our trimming tool? I mean, do we want to try that? The thing about the trimming tool, it kind of looks awesome when you first see it because it starts to remove things, but then it starts to increase the number of dimensions. Uh, it might be okay. Let's see if we can get by with that in this one here. So let's start cleaning up things that are not going to be part of, look at that, not going to be part of our extrusion. So this takes a little bit of artistic work, but did I pull it off? I think I did, because if you move this around right here, you basically see that I got the extruded shape. And you can probably see right here that we have this. So trim is not something you normally want to use. Um, and the reason is um, most of the time it starts to distort things if you don't lock them down ahead of time. It's safer to do the split and change to construction lines. And so if your picture is messing up, I recommend you do that instead. Okay, so that means you know what I'm talking about, right? Let's see. So I'll just do this other one as a split. All right, so we say split, you can say do this one, and then you say, all right, I want to turn this into a hidden line. And so that way it doesn't become part of the extrusion. And then you'd also do a split on this one right here. And you really want it to go all the way around to that spot. Hopefully it lets you turn this one into a construction line. And nope, didn't do it. So click on this, and even this little segment right here. Okay. And so I achieved both of them. I achieved the same thing on both of them, and that is making an extrusion area. And you can see that right here, I have a little fillet here and probably a fillet around here. It's going to be too sharp. It's going to cut into the metal. So we want to make a little fillet here. And we might just play around with this one, see if 2 millimeters looks good. It might be a bit much because it looks like it's pretty sharp actually. So we just put like a 1 millimeter fillet on that one, and it changed both of them at the same time. However, on this one, I don't think a 1 millimeter fillet is going to do it. Or will it? No, I don't even think it noticed anything. Oh, wait, it did it. Yeah, 2 millimeters looks good. All right. And then you extrude that. And this is pretty thin. I want to say it's like 2 millimeters thick. And Let's see, let's center the part. Isn't that a beautiful C-ring? These are made out of steel, so let's go up here to right click this one, properties, and let's find something that's going to give it a good appearance. Probably just like cast steel. Let's see if that changes the color a little bit. Close, a little bit of the appearance, a little bit shiny. And there is our C-ring, folks. So hit save right here. We got 2 out of 3 parts done. Keep in mind, as you probably already know, you can fast forward through the video if I get long-winded on a part. Sometimes every little bit of these things is needed. On this next one, I'm just going to go File New and still stick with this one here. I'm immediately going to save it as bearing. This is what the wheels require in order to function properly. Going back to my same directory, bearing, and we will put all these together in an assembly. Not today, but as we start to move forward, could connect it with our wheel. And the thing I can tell you about this very simple thing is it's got just 2 circles and an extrusion. It's really that simple in its basic form. Okay. So what am I talking about here? I'm talking about not that one, not this one, not this one. I'm talking about this piece right here, number 4. And so I'll go and look and see if it's got some aftermarket alternatives or like that. Oh, you know what? That might tell us something about the size of it. Wouldn't that be great? So what we're going to do is say to our Google here, um, we'll say, what are the dimensions of a queen size bed of that right there? Now, I really think that these 2 things, that all 3 of these things is it. This might be inner diameter, outer diameter, and thickness. Wouldn't that be awesome? And how close did I get? I was spot on, right? So sometimes you can do this easily. You're going to be an engineer one day, and being able to find these parts in a catalog and know what these things mean is going to be really powerful to you because your coworkers are not going to know how to do this. All right, so this is practical engineering stuff here. All right, so we're going to say 44 by 72 by, by 31.1, 33.1, 44, 72. Here we go. 44, 72. How easy is bearing making, right? I'm really kind of glossing over things a little bit because what's inside of this beast is not um, trivial. Um, the thing that's inside of this that I'm kind of just glossing over as not being important is this has actually 2 pieces and there's roller bearings in between the 2. So this inner cylinder rotates with respect to the other one. However, if we're doing just a 3D model, we don't need to simulate the bearing in this way. We just do it with the constraint instead. So it's simply, for us, it's just going to be a part that slips on to the hub and connects to the knuckle. And the knuckle will come in the next week or so as far as that design. We do see maybe a little bit of fillet on there, so let's make it look good because that doesn't look realistic. I think it's got like a shiny stainless steel appearance to it. So let's see if we can find something like that under eye properties, physical, and we will go down here. Do we have something like stainless steel? Because I do remember it having more of a shiny appearance to it. There we go. But it doesn't have these sharp edges, right? It shouldn't really have that. And yeah, I might be making a mistake by adding the fillets after the fact. I think that I might be, but let's find out. So 3D model, fillet, and we'll get a preview of what those look like. I think I'm okay with the 2 millimeters. Now the question is by adding those fillets, did it actually change the material? So sometimes what will happen is it doesn't recognize the fillets as being the same material. But yeah, it looks like it kept it as semi-polished stainless steel, so we're actually good. If you want to get a slightly different look at this, maybe more realistic, you can change the visual style to just shaded like that, and it looks pretty close. We can even put that little black strip in there to represent the separation between the two. Should we do that? Yeah, I don't know. Because this part is so simple, maybe we should go ahead and do that just for simulation purposes so we can remember what this part is. Let's see how quickly we can do that right here. Let's just make some artistic choices by picking two circles like this and clicking, I guess, let's do like another extrude. Can we do that? Um, and the way to do that is to come back to this extrude and say, edit this feature, but I want another one. Okay, so let's see if it'll let me do that. So another, when you want to do another one, you say plus, and then you go looking for that drawing that's got the split in there. Now we could do that. You can see it's just going to make a vacancy through there. That's a cut. Let's do this and assume that it would let us do. Now what's going on here? Okay, it went the wrong way. Let's assume that it treats this as different material when you click OK. Yeah, it says you're doing basically the same thing. Okay. Basically, it's saying I can't see this as a separate object. So I'm going to trick it and I'm going to say, let's do that again. I'm going to do the cut. And then, so in other words, I'm going to cut out the aluminum. Let's see if I can trick it into doing that. All right, so this is the part we already did. We're going to say plus a cut and then plus a fill. So first of all, we need to cut it out. And then we need to come back here and refill it in with some different material. And it's actually reading my mind. So it actually kind of did that. And you can't see it until you go like this and then say, make this black. I hope I didn't lose anybody on that one. Kind of just, oh, wait, where'd it go? Okay, it did not recognize that it was there. Let's see what happened here. So if we go back over here to edit feature, and we'll just make it a little bit longer, like 35. Make sure it sticks out of one side. Okay, yeah, it actually did kind of show up here. I'm wondering why. Yeah, that's weird because I did the cut right here. Huh, did not quite expect that. So if we just right click right here, it's suppress features, and it leaves a gap. So shouldn't anything I put in there be the color that I select? What if I make it a separate type of extrusion? And then I say, show me my sketch again. Okay, let's try to do it. Okay, where's the outer? Where's it at? Right there? Or is it going to let me select that? I'm not so sure it's letting me select that. Nope. Oh, I think it's asking what surface do I want to put that on? Gosh, not sure. I want to make it visible for a moment and then try to do a separate extrude. And perhaps I'm spending too much time on this. I just realized what it might be. It's that I made the whole part out of aluminum. Yeah, that's what I did. Okay. So what I could do is come back over here to the bearing and under the eye properties, I should not have made the whole part out of stainless steel. Just make it, can I delete it? Generic? Is there a word generic in here? It's supposed to be set to generic. Okay, apply. Okay. And then once you close this, you should be able to select the two areas, like this one right here, just make it green or something, turquoise. I did not even recognize that it's there. It should be a different color right here. But you know how we do things, right? We're going to trick it just like we did before. So what we're going to do is, let's just delete this last one. And we will unsuppress that feature. And we're going to use the old Bruton trick here. And that is to edit the feature and just make it slightly bigger. So 33.2. And then we'll also go back in the other direction and we'll just go zero point 0.1 direction that way. And did it work? Can we hide our sketch? I mean, it's not a standard way to do it, but we're going to call it done. As long as we can come back to this original one and say that at least that one is stainless. Stainless steel. Can't stain that surface. Stainless steel. There's galvanized. Let's just make it polished steel. Did it mess up again? Kind of. Now you see the error in the fillet right there. And so it's weird that when you use this approach, you have to turn the fillet also into something that's steel because it's a separate object now. I really didn't mean to do all of this crazy extra work, but we have a good looking bearing right now. Let's go ahead and save that. And let's call it a day on that one right there, because we went through some tedious three parts here with the rotor, the C-ring, and the bearing. I will see you in the next video. Have a good one.